Alrighty, I wanted to go over how to solve by elimination. So let's just jump straight on into it. The start thinking part says, when you were solving a system of equations, given equation A is y equals 2x plus 5, and equation B is 5x plus 2y equals 10. After your first step in substitution, the equation becomes 5x plus 2 times 2x plus 5 equals 10. Question number one says, why can't equation A be solved on its own? Meaning you can't get a variable equals a number. And the reason why is because there are two variables. Why can't equation B be solved all on its own? Well, same deal. There's two variables in there. The next question says, why can the resulting equation be solved after the first step of substitution? When you look at this, both equation A and equation B both have two variables. So you're not going to be able to solve in the form of one of the variables equals a number. But after you do your first step of substitution, you should be able to see here that you are able to solve this because there is only one variable. I know it looks like there's two, but they're both x, which means that you would be able to solve this because there's only x's in the equation. So that's one of the beautiful things about solving by substitution is you used to have two variables and now you only have one. Now here's the concept of elimination. You can add two equations and or you can subtract two equations. The goal is that after you do this, you are going to eliminate a variable. That is why they talk about this as elimination. Just like above, I talked about how equations A and B had two different variables, and then once you got rid of one of the variables, you could solve your equation. Same deal here. If we could just get rid of just the x's, then the y's are going to be able to be solved for. If you get rid of the y's, then you could solve for the x's. So why does this work? We talk about what are some things that you can do with equations to ensure that the resulting equation is equivalent to the original. Well, you can add, subtract, multiply, and divide both sides by the same thing. Keep that in your thoughts as we go through this problem, and then I'll talk about why the concept of elimination actually works. So the sample problem here, it says solve by elimination. You have 4x plus 2y equals 10 and 3x minus 2y equals 4. As you can see, if I add these together, the 4 and the 3 will add to be 7x, but the 2y and the negative 2y, when you add those together, since they're opposites, it's going to eliminate the y's. And then you would go over and add the 10 and the 4 together. When you add that 10 and 4, you have 14. So what you can see here is by adding the two together, I ended up with just 7x, no y's on that side, equals 14. And when I solve, I get x equals 2. Now, just like in substitution, once you solve for one of your variables, you just need to substitute it back in. So I substitute 2 back in for x into either one of the equations. I decided to substitute into the top equation. And when you do that, you end up getting y equals 1. So the location is 2, 1. You would have gotten 2, 1 if you solved by substitution. You would have gotten 2, 1 if you solved by graphing on here. Now, if you look at this, these two equations, if you tried to solve by substitution, the top one, if you got it in, let's see, y equals form, you wouldn't have any ugly fractions, but every other one, if you tried to get the top in x equals form or the bottom in x or y equals form, you would end up with really icky fractions that you would have to substitute back in, which would not be fun. Now let's bring our thoughts back to why does this work? I've been teaching this for many, many, many years, and it's never like occurred to me to ask myself, why does this work? Why can't you just go over and add two equations together? Well, when you look at this, in this case, you would be adding the 3x minus 2y to the left, and then you're adding 4 to the right. That doesn't seem like you're allowed to do that. Why can you add one thing to the left and then you add something else to the right? But since the bottom equation says 3x minus 2y equals 4, when I add 3x minus 2y to the left and I add 4 to the right, since 4 equals that other stuff, it's kind of like I am adding 3x minus 2y to the right as well. Or when I go over and I add 4 to the right, when I add the stuff with the x's and y's on the left, since that equals 4, it's basically like I'm going over and adding 4 to that side as well. So this is legal because I'm basically adding the same thing to both sides of the equation, and that's totally legal. Now let's go ahead and take a look at some other ones. We have these. I'm trying to figure out if I should add or subtract. You can see it's a 5 and a negative 5, and since they're opposites, when you add opposites, they eliminate. So the 2 and the 6 are not going to go away. 2 plus 6 does not give you 0, but 5 and negative 5 are going to give you 0, and all we care about is eliminating one of the variables, because we can solve if we have the other variable. When I add these together, you get 8x equals 8. When you solve, you get 1. And then you substitute 1 back into either the top equation or the bottom equation. And when you do that, you get 3. So the answer is 1, 3. Now on B, once again, should I add or subtract? Since we have a 6 and a negative 6, and those are opposites, I should add those two together, because opposites, when you add them, you get 0. I understand that I did not eliminate the x's, and I didn't want to. I didn't eliminate the constants, and I didn't want to. I just wanted to get rid of one of the variables. So you can see I added them together. I solved, I got x equals 2, and then I substituted 2 back in, and I was able to get the other variable. Now on this one, you can see that we have a 3 and a 3. If I go over and add those, I'm going to get 6. I don't eliminate it. When I add the 3 and the negative 4, I'm also not going to eliminate those. So in this case, it's better for us to subtract rather than add. And when I subtract, you got to be really careful, because this is 3 minus negative 4, and minus negative means plus. So 3 minus negative 4 is the same thing as adding, and you would get 7y. Negative 9 minus 5 is negative 14. And when you solve, you get negative 2 for y. And then you sub it back in, and you're able to get negative 1 for x. Where do you sub it in? To either one of them. Now, a little trick. I prefer not to subtract ever, because I always mess up on the minus negatives. So what you can actually do is you can distribute a negative throughout that bottom equation or throughout the top equation so that they are opposites. So if you look at after where it says or, you can go over and distribute a negative into that bottom equation, and you would end up with negative 3x plus 4y and minus 5. And then you're going to add them together. And the reason that this works is if you ever had like 5 minus 2, 5 minus 2 is the same thing as 5 plus negative 2, adding the negative. So when you do that, then you don't have to worry about minus negatives, and you would end up getting the same exact answer. So just be really careful. If you decide that you do want to subtract, be careful with minus negatives. And then also when you substitute your variable back in, if you substitute into that bottom equation in this case, make sure you understand that is not a negative 3. That was a minus. If you substitute it into the equation after the word or, then that's totally fine. That is a negative 3x because I've switched all the rest of the signs. Students then went over and solved these. The first one, you could just add them together because you had a 2 and a negative 2, and that's going to eliminate the y's. You would solve for x. Once you get x, sub it back into either one of the equations, and you end up getting y equals 0. Don't get freaked out. Y equaling 0 is totally fine, because you have an answer of 2, 0. That means if you solved by graphing, you would have the intersection at 2, 0. And then on this last one, since it's a 3 and a 3, they're not opposites. You wouldn't add, you would subtract. If you want to do that, that's totally fine. But in this case, you need to see that you would do 10 minus negative 2, which is adding 2, and that gets you 12. You would solve, and you would get x equals 3 and sub it back in. Another option would just be to distribute a negative 1 through everything inside of that equation. So the positive 2 becomes negative, the positive 3 becomes negative, and the negative 2 becomes positive. So that is another way you can do it so that you have opposites and not the same thing. Now on this one it says, Jasmine goes to the store and buys 5 hats, 2 t-shirts, and spends $93. She returns and buys 7 hats, 2 shirts, and ends up spending $118. How much did each hat and each shirt cost? There was no tax on the purchase. So when you look at this, the two situations we're writing equations for are the first time she went to the store and the second. The first time she went to the store would be 5x plus 2y equals 93. The next one would be 7x plus 2y equals 118. And then you can see how I solved. They were the same, so I had to subtract. Once again, you could have just switched all the signs on the bottom equation, got a negative 7x, a negative 2y, and a negative 118. That way you could have just added them rather than subtracting and being worried about negatives. When you solve this, you get x equals 12.5 and y equals 15.25. You know, a lot of people would get a little confused and think that that was talking about the number of hats and the number of shirts, but we already knew how many shirts and hats. So this is talking about the cost of a hat and the cost of a shirt. Now here's your homework. On this first problem here, they are opposites, 3 and negative 3, so you just add the two equations together. When you do that, the y's go away, and you just end up with x. And when you solve for x, you get x equals 2. And then you are going to substitute back in to find out what your y is. On part B, once again, they are opposites, a 2 and a negative 2, so you can add these two equations together. And when you do that, you end up getting 8y equals 24, so y equals 3. Substitute the 3 back in to either one of the equations, and you end up getting negative 2 for x. On C, they are the same, 2y and 2y. So you are either going to have to subtract or distribute a negative into one of the equations to all three parts so that they are opposites, and you can then add. I just subtracted. 6 minus 4 is 2, 8 minus 4 is 4. The reason I just subtracted was because there were no negatives involved, and I knew I was not going to mess up. When I substituted back in, I got 2 and negative 2 as my answer. That's what you would have gotten if you solved by graphing or by substitution. On the next one, they are going to be the same, so you're going to have to subtract. And when you subtract, you got to be careful because you're going to have the 5 minus negative 2. 5 minus negative 2 for the y's is going to be the same thing as adding the 5 and the 2. What I decided to do is distribute the negative, getting a negative 3x, a positive 2y, and a negative 4. And then I just added because now that they're opposites, I can add. You end up getting y equals 1, sub it back in, solve for x, and you get x equals 2. The next one says one of the equations in the system is 3x plus 2y equals 10. Give another equation such that when you solve by elimination, you would end up eliminating the y. So since I'm eliminating the y and we had 2y, I made the other one negative 2y so that it would eliminate. And then I just kind of tinkered. I figured out what the x had to be and what the constant had to be so that when I added them and I ended up solving the equation, I would end up getting 2. And I found that a good answer would have been a 1x and a negative 2. Because when you add those together, you get 4x and an 8. And when you solve 4x equals 8, you get 2. So there's many other answers you could have gotten, though, for the second equation. Now, going back to this was a problem that a lot of people messed up on the quiz, so I decided to throw it back up here. You must pay 8.25% tax on non-food items in Tucson, but no tax on food items, right? But do not solve the equation that represents total price when you buy a $6.50 non-food item, which is taxable, and then a $4.75 food item. So that's going to be total equals the 6.5. That's just the cost of the non-food item plus the tax on that, which is 6.5 times 0.08. Remember, 8%, and that is not supposed to be 0.08. Darn it. That is supposed to be 0.0825. 0.0825. For some reason, I thought it was just 8% when I made this key. So just know it is 0.0825. Every place where you see a 0.08 in this problem, it's supposed to be 0.0825. So you can see how I did that. It was cost of the non-food item plus the tax plus the food item. Technically, you could go over and say 6.5 times 1.0825. Don't forget the 25 on there. The next one, the only difference is they don't tell you how much the non-food item is, so that just becomes an X. Once again, do not forget the 0.0825, not just 0.08, that's just 8%, and we wanted 8.25%. And technically, you can have the 1x and the 0.0825, and that would get you 9.75 plus 1.0825x. And then lastly, they change it up a little bit, and they make it so that you know what the total cost is, which is $20.30. You can see how I did this. Just once again, make sure you have 0.0825 because it is 8.25%, not just 8%. Sorry about that. And this last one says, what mistakes were made in the following steps when a student is trying to solve the system by substitution? Well, first things first, they didn't distribute. That's a huge one that they did. Once they substituted in what y equals into y in the other equation, they accidentally forgot to distribute. And then after that, they just messed up when they were solving the equation. You're supposed to combine those like terms to get 20x, not go over and subtract 6x twice from the left. That's not legal to subtract something twice from the left. All right, hopefully that made sense. Thanks a bunch. Bye.